Hey, welcome back to Math with Patrick. Today is August 6th, and we're solving problem number 218 from the Daily Epsilon calendar. And we should figure out why the answer today is 6, because it matches today's date. And I think this problem is really easy. I think the only difficulty here is really just understanding the notation of the math. And once you can read the math, then it follows really quickly of what the answer is. So this I would say out loud as for the sequence a sub n, the sub part just stands for subscript. Like whenever you write stuff below the normal line, it's a subscript because it goes like below. So for the sequence a sub n, a sub 1 is equal to 2. And this is just saying that the first term of my sequence is equal to 2. So it's basically just like I have a list of numbers, and the first number that I have is going to be 2. Maybe I'll make a table. I could say that this is n, which is kind of like my sequence number. And then I could write a sub n, and that's going to be 2. Because if I put this 1 right here, n is equal to 1, I could replace this n with a 1, and then I'm basically saying that a sub 1 is 2. So I will just organize my thoughts in this table. This second equation gives us a rule of how to go from one term to the next. Like, let's pretend I want to figure out what a sub 2 is equal to. So if I replace this n with a 2, now I will have a sub 2 equals, and then all I got to do is just replace all the n's that I see with the number 2, because I said, n is equal to 2, and then let's just see what the math says about what a sub 2 is equal to. So we're going to go 2 times, and then a sub n minus 1. N is 2, so we'll go 2 minus 1, and then plus 1. That 2 minus 1 we could simplify to just 1. And then now we get a recursive relationship. Recursion is when your next term is based on the previous term, or your next term is based on the current term, or your current term is based on the previous term. There's a different ways to say it out loud, but essentially to figure out what's going on at step number 2, I need to look back at what's happening at step number 1. There are some other recursive relationships that look back to further steps, but in the most simplest form, this recursive relationship just looks back to the previous step. Well, a sub 1 is equal to 2, and so now I have 2 times 2 plus 1, and that is going to be 5. So n is 2, a sub n is 5. And then I guess we need to figure out what we're doing with this sequence. A sub x is the first composite number of the sequence. So it looks like this is going to be where I'm finding my answer today, because this n is the subscript. X is always what we're solving for in this calendar, so x should be 6 today. And then it's saying that a sub x is the first composite number. So all of these are going to be primes, supposedly, up until we reach x. Since I know that x is 6 today, I know that I will need to go this far in my table, and hopefully this is the first composite number. 2 and 5 are both primes, and that's just because we can't really break them apart with multiplication into any other numbers besides 1 and itself. Like, for example, 6 is a composite number because we can break it apart into 2 and 3. So let's just keep trying and see what happens. A sub 3 is equal to 2 times a sub and then 3 minus 1 plus 1. That 3 minus 1 we can simplify to 2, and then a sub 2 we know to be 5. And so essentially, I won't do those steps for the next few ones. We know that this number right here is always just going to be the previous in the table. So it looks like our rule is take the last number, double it, and add 1. And thinking about it in terms of rules in arithmetic is going to make the calculations a lot faster, as long as we can see that we double it first, then add 1 next. So you take 5, double it, and add 1, we get 11. You take 11, double it, and add 1, you get 23. And both of these are prime numbers. You could try looking for other numbers below it that multiply up to 11 or 23, but you're not going to find any Following that pattern, doubling and adding 1, we're going to get 46 and then 47 once we add the 1. 47 is another prime number. Again, you could try multiplying two smaller numbers together. You're just never going to get 47. And if we double 47, we're going to get 94. And then adding on the 1 gives us 95. And I can already tell it's 5 times something. I know 5 times 20 is 100, so 5 times 19 should be 95. And then now we found the first composite number of the sequence, and it's when our subscript is a 6. So x equals 6 today. That matches today's date, and we're all done. Thanks for coming along, as always, and I'll see you in the next video. Bye.